Hello, this presentation is titled Random Mondrians. My name is Anton Antonov. Today is July 27, 2024. Random Mondrians, they look like this, what I'm generating here. This type of art was started by a Dutch painter named Piet Mondrian approximately 100 years ago. Piet Mondrian, he was a part of a movement called the style, which I think in Dutch means the style, and that movement embraced abstract pared down forms, and it was a reaction to the decorative excesses of Art Deco, at least partly. So pretty much like the programming language Python and Perl. Python was created by another Dutch guy who got scared or annoyed with the excessive nature, postmodern nature of Perl, and he created a programming language in which the guiding principle is there is one obvious way to do it, and everything else is difficult. All right, so since I mentioned Python, I did install a few Python packages for generating Mondrians. None of them are particularly tunable, but one of them here you can see it, Mondrianish. It uses the command line and displays Mondrians in the terminal, which is kind of cool. And so here, this package JavaScript D3, which I'm using to show the Mondrians, which I implemented the Mondrians, you can see we can use it from the command line and generate Mondrians and display them in the browser. So if you don't want to use this Visual Studio Code integrated development environment and the Jupyter notebooks, you can generate Mondrians in this way, because of course you want to observe Mondrians and be influenced by them. All right, so before going further, I would like to also mention that I got inspired to do this in Raku, to implement this in Raku by seeing and using this function Random Mondrian from the Wolfram function repository, this Mathematica, and uses some kind of interesting tunable elements about the splitting of the rectangles. I'm going to explain a little bit what the splitting of the rectangles means, and so let me zoom out, I think, here. So every iteration step, we start, say, with one rectangle. Every iteration step, we decide which rectangle of the previous step to be split, and how to be split, and with what distribution the splitting is being done. And so this is what is happening here. This one I'm demonstrating basically successive iterative steps for doing this. So I'm going to use this one. I'm not going to go for all of them. I think by default the number of steps is 7. All right, so in order to do the splitting, I'm using beta distribution, and beta distribution is based on the gamma distribution, and which in the programming generation of random variates for the gamma distribution is not trivial. I mean, it wasn't that difficult either, but I had to spend some time doing it. So you can see here I have generated some random variates with the beta distribution, and here you see the histogram and the box whisker chart, right? So if you see here that in this bubble that the median is 0.5, actually you can see here both the mean and the median are very close to 0.5. This is because for the beta distribution, the mean and the median can be, so actually the mean only can be computed by using the first shape parameter, 10 in this case, dividing it by the sum of the two. And you can see this here in this write-up. I asked Gemini to give me the most important formulas for the beta distribution, and so you can see it here, right, how the mean is being calculated. It's exactly what I said, right? So another thing here, beta distribution is, I'm using it, and the original author in Mathematica who made this Random Mondrian is using beta distribution because it is defined between 0 and 1, and that's kind of handy feature when we're doing the splitting. So another thing here, I did mention that beta distribution is based on the gamma distribution. You can see it reflected here in this formula. All right, so enough theory. So let's actually generate some random Mondrians. And so I think I need to zoom out again. So what is happening here in this random Mondrians is that I have diversified the white. So by definition, by default, the standard color palette, primary colors for the Mondrians is this one, the hexagonal colors here. I have diversified the white, right? I have added 3 more white colors, floral white, mint cream, old lace, and we should be able to see this in the white generation, right? So we can see here that there are different shades of white. So Piet Mondrian, he painted his paintings, the white elements in his paintings in such a way that they're more compelling, more arresting, the white elements are. And the way he painted the white elements was with different strokes, different number of layers, and so forth, right? So this is a reflection of that, right? Using this diversified white color is a reflection of that. Another thing we see here is that I am selecting randomly the number of splittings, the number of iterations, and the thickness of the stroke, right? So again, let me generate a few more. So going further, another way to produce Mondrians is to, first of all, I can change the distribution, not just beta distribution, I can use normal distribution, but another thing to do here is to use color schemes, which are provided by D3GS, the JavaScript library D3GS. So you need to know the color schemes in order to put them here, and so they're basically selected here. You can see in the titles of these images that the selected scheme and the number of iterations is being reflected in the title. All right, another thing to do is to have this jittering effect of the rectangles. So let me generate a few more here, and you can see that I have changed the background, which in my opinion changes the perception of this Mondrians. We can use, of course, different colors for the black lines, for the outlining edges of the rectangles. I think black is actually the best one, and maybe I'm too conditioned at this point looking at Mondrians and that's why I'm finding black to be the best one. All right, so how is this working? And I'm going to zoom in here. So too much. So here I have this function in Raku which generates the rectangles pretty much with the iterative process I outlined above. You can see here what is the summary, but of course we need to visualize it. So generation of the rectangles in Raku is fine, but how do we visualize it, say using JavaScript, the libraries, some library of JavaScript, and I'm using D3GS as I mentioned. So here I'm making a LLM persona, large language model persona for code writing with D3GS. Here I am converting the JSON to JSON, to a JSON string, the rectangles I generated above. But before going with that, so let me show here the code which is being generated by the code writing persona, right? It generates this JavaScript code, and I have copied and pasted this code here. I have modified it slightly in order to be able to visualize it in Jupyter, right? And so I'm going to use these rectangles which I was generated above, and going to execute this, and yeah, we basically see here the result. All right, so of course instead of doing Mondrians with, say, ad hoc in this manner, what I was showing here with JavaScript code and LLM generated code, or using the implementation which is already packaged in the JavaScript D3, we can ask some artificial intelligence or LLM kind of services to generate Mondrians. I'm not going to do that. This is generated with DALL-E. It just takes like 30 seconds to generate this Mondrians. I think this is the first one I generated, and in some sense the best one, the most indicative one. I'm going to use the opportunity to show something else here. So this function here, data import, is a universal importer function. It can import PDFs and HTML images. So what is happening here is that half of the time, 2.5 seconds, is taking this function to ingest the PNG image, the portable network graphics image, into a base64 string, and then the other half is being used to display it as an image in this Jupyter notebook, right? If we're using the function GSD3 image display, right, this is instantaneous, right? So it is kind of cool. Last thing to mention is that, of course, we can do be a little bit more artistic. So one of my online collaborators created a dozen or more than a dozen images like this. This is reflecting a certain fashion shows in the mid 60s last century, in which the fashion models are wearing Mondrian dresses. And from this set of images my collaborator created, I selected this one because the field in the background is kind of Mondrianized. It looks a little bit like Tetris. And yeah, it's a compelling image. All right, thank you. This was it.